The next big idea we have here is the triangle exterior angle theorem. Angle 1 right here is an exterior angle. It's on the outside of the triangle. Now, by now you should have measured angle A and angle B right here and angle 1. And you should have noticed something. If I add up those two, it should give me angle 1, or it should be really, really close. You also might have noticed that angle 1 is greater than angle A. And the measure of angle 1 is greater than the measure of angle B. Those also would have been valid observations. What we're worried about here is the triangle exterior angle theorem, where exterior angles A and B, if we add them together, it should give us angle 1. Well, I'm going to pause here, have you pause the video, and try to fill in this proof right here. Let's see how you can do on your own first. Alright, by now you should have paused the video and try to fill this in here. Because of the triangle sum theorem, we know the measure of angle A plus the measure of angle B plus, I can't just say angle C here because the C could be this one or it could be this one, so I got to use 3 letters, angle BCA or angle ACB equals 180 degrees. Since angle ACB and angle 1 form a line, we know that they add up to 180 degrees. Or you could say since they form a linear pair, we know they add up to 180 degrees. Angle ACB plus angle 1 is equal to 180 degrees. Since they both equal 180, since A equals B and B equals C, we can set them equal to each other. So the measure of angle A plus the measure of angle B is equal to, plus the measure of angle ACB is equal to, I'm not going to say 180, I'm going to say it's equal to the measure of angle ACB plus the measure of angle 1. Then we can subtract angle ACB from both sides and get measure of angle A plus measure of angle B is equal to measure of angle 1. Not too tough. QED, we're done. Alright, solve for X here. Let's do a couple practice problems. Try these on your own first, pause the video, and then when you're done, I can show you what I got. Alright, there's a couple different ways to do this problem. I can use the exterior angle theorem and say this angle plus this angle is equal to 100. And that's going to give me 5x equal to 100, so x is equal to 20. Now that I've solved for x, I'm going to find the measure of each angle. Get 3 times 20, and that's going to be a 60-degree angle. That's going to be a 40-degree angle. Another way I could do this, though, and it works on this problem because I actually have a number right here. There's 180 degrees in the line, so if that's 100 degrees, I can say this is 80 degrees. Now what I can do is to say, I could just use the triangle sum theorem. 3x plus 2x plus 80 equals 180. Subtract 80 from both sides. Ooh, I'm at the exact same spot I was before. 5x is equal to 100 and x is equal to 20. So either way works right here. But always make sure we answer the question. Solve for x and found the measure of each angle. So this angle is 60, this angle is 40 degrees. We're going to do the same thing for the last question here. This one, I can't really do that, at least not too easily. I don't know how many degrees this is, so I can't figure out this one and add these all up to 180. So I'm going to have to add these two together and make them equal this one. By the exterior angle theorem, 25 plus x plus 15 has got to equal the exterior angle, 3x minus 10. From here, it's just algebra. I can combine my like terms here. X plus 40 is equal to 3x minus 10. Add 10 to both sides. x plus 50 is equal to 3x. Subtract x from both sides. 50 is equal to 2x, so that's going to mean x is equal to 25. And it says find the measure of the exterior angle. Always got to make sure I go back and read the question. So if x is 25, that's 3 times 25 minus 10. That's going to be 75 minus 10. That's going to be 65 degrees. So that's 65 degrees. Should be able to figure out the other one here, just for fun here. That means this is going to be 115 degrees, because they have to add up to 180. And if I take this 25 degrees in here and plug it in here, that means this angle right here is going to be 40 degrees. So this triangle would be an obtuse triangle, because I've got 115 degrees right there. Now you may be saying to yourself, Mr. Kuhne, that is clearly not 115 degrees. I know. It does not look like 115 degrees. But pictures can be deceiving, so we just have to use the numbers that they give us. For example, you might say, Mr. Kuhne, those lines aren't parallel. I could say, well, you say they're not parallel, but what if I did this? What if I drew some trees over here and drew some ties right here and say, oh, these are railroad tracks. Well, and railroad tracks, as we know, are parallel. So even though they don't look parallel, they actually are parallel. Just like right here, this may not look like 115 degrees, but according to the picture, it is 115 degrees. And those are your notes on the triangle exterior angle theorem. These two angles right here have to add up to equal the exterior angle.